Hi, welcome back. We're going to start with activity 8. All right, measure out 5 mils of your
Which one?
yellow and blue and put them into 2 separate test tubes.
Way too high.
It's okay. Get a pipette. If you ever measure, this is where your pipettes come in handy. Remember to put it into your waste, not into your initial container. There you go. Okay. Okay. Make any observations you can about your test tube. Measure the temperature. Repeat the process with the yellow solution. No, that's okay.
I don't think you're using it again. Beginner here.
This is how we learn. Okay?
I never said I was perfect.
Make your observations about your individual test tube.
Now we get to dump this out.
Okay?
Right?
Nope.
Nope.
Okay? So you make your observations about your initial test tubes.
Stop doing what I just did with the yellow.
Take your temperature.
Why'd you leave the pipette?
Okay? Then you're going to take the 2 test tubes and combine them. Test for any endothermic or exothermic changes. You'll measure the temperature and write down any changes you see, observations you see. Now, of course, we don't want you to see what we see. That's for you to decide. And that's activity 8. Is this a physical or is this a chemical change? Please note, there's always a chemical reaction. You can't just say nothing happened. Something happened. Now, whether it's physical or it's chemical is up for you to decide. Okay, so we'll move on to the next experiment. Okay, while my assistant here cleans up our test tubes. Activity 9. We're going to do HCl and magnesium ribbon. Now, for magnesium ribbon to thoroughly make contact with our HCl, this is where your emery board will come in handy. We need to roughen up the magnesium ribbon, okay? So, we're going to take the ribbon, and you won't actually need the entire piece. So if you have scissors handy, which of course they didn't tell you to provide, so we'll get some scissors for you. You go ahead and start roughing up the ribbon. I know you have some around here somewhere. There. I saw them. Okay. All right, we're going to cut off a piece of ribbon here. Okay. Okay, and we're going to take 5 mils of the HCl. I know I have to constantly read these. Okay. Is this cleaned down already?
Yes.
Okay.
I hope so, otherwise I'm a bad assistant.
We're doing just fine. Okay. Okay, again, we're going to measure the temperature. We're going to note the color of our solution. And now we're going to take our ribbon and we're going to drop it in our solution. Now this is the best part, by the way. Oh, gosh. We see a reaction going on. And I feel some endo or exothermic activity going on as well. So there's lots of observations going on. And by the way, this is not one you want to waft towards your nose. You will see plenty of activity going on in this particular reaction. So when you do activity 9, take a good look at what's going on. Okay, I'll hide this one. All right, so activity 10.
I can't dump this down the sink.
Yeah, you can. Just grab the ribbon. Get the ribbon?
I was gonna get it, but then
There you go. All right, activity 10. Table salt. Go ahead and pop. I just want to give a safety warning on activity 9. The byproducts of the reaction are flammable, so please be aware to have all flammable items such as the tea candle and any cigarettes or anything that you might have lit put out prior to doing any of these experiments or activities, just for your safety. Even though this is addressed at the beginning, it's just a reminder. Okay, activity 10 is where we are. Okay, so we are going to look at copper sulfate and table salt. So we're going to measure out 5 mils of copper sulfate. My assistant's going to help me there. And I've already pre-measured 2 grams of
5.
Yep, 5 mils. Table salt. Sorry. I've already measured it out. So this is just iodized salt. However, if you don't have table salt in your house, if you're a vegetarian, anything that has a chloride in it, such as potassium chloride, magnesium chloride, swimming pool information, you could use any of those, because what you're looking for is a chemical reaction, so we're swapping out. And you haven't gotten into the reactions yet, that comes a little bit later, but if you don't have table salt and you have potassium chloride or calcium chloride for that matter, you can use those in replacement of sodium chloride. Okay, all right, so again, in between these activities, we have actually cleaned up our test tubes, and you haven't seen that. So just remember, please clean your test tubes in between your experiments, because these are reusable. And so what we're going to do here is note observations here, the temperature of your copper sulfate and your table salt. Note that it's solid, it's granular. We have blue, it is clear, and you are going to add your liquid to your solid. Okay. And we're going to look then for the chemical reaction here. Now my assistant's new, so she wants to see what observations and what kind of chemical reactions are going on. So, although you are supposed to be making these observations as well, we went ahead and went through with the complete experiment. And so she's notating this, and she's feeling whether or not we have an endothermic or an exothermic reaction. Was a precipitate formed? And so on. So she's going to go ahead and dispose of the chemical reaction. Okay, so that's activity 10. And while she's cleaning up, we will prepare for activity 11, the last two. All right, so we're going to go back to our aluminum. Okay, so in the first experiment, we worked with our magnesium and hydrochloric acid. Now, from activity 4, we had this aluminum whey cup. Now we're going to actually reuse the aluminum whey cup. We're going to cut it into pieces. So we need several small pieces. That can be used to have a chemical reaction. So prior to the actual chemical reaction, we need to notate some information about it. So make some observations. One of the things that you want to note about aluminum, aluminum is malleable, meaning that it bends. It's a soft metal. It's on the shiny side. Okay, all right. We're also going to use our copper sulfate again. Okay.
How much?
We need the stuff you disposed of. So we're going to use 5 mils here.
Then why'd you tell me to dispose of it?
Okay. So we're going to make up a copper sulfate and salt solution using 5 mils. Don't dispose of your copper sulfate from activity 5. So we're going to remake our solution. So you're actually going to get to see activity 10's results. Over the right shoulder, right, for good luck? Not what it's supposed to be? Oh, left. My son says left. Okay, so hopefully this is good luck. Okay. I'm gonna add this. Okay, so here's our solution. Notice that our salt has changed colors. Our solution has also changed colors. It went from blue and clear to now it is cloudy, and our salt has turned a yellow color. Okay, these are important observations. And now we're going to add our aluminum. Now a few more pieces. but I'm not going to show you what happens to the aluminum. Okay.
Did it just do that?
Yep. So we went from shiny and malleable to
Nothing.
nothing. There's a reaction there, look.
Nothing happened.
Lots is happening. That's activity 11. Ooh, I hear something.
I'm glad I'm taking chemistry.
Okay, last activity, activity 12. My assistant here is roughening up our nail. We're going to use copper sulfate, and we're going to see what happens when we put copper sulfate on a nail. Okay, so measure out 5 mils of the copper sulfate. And you do have enough chemicals that if you do make an error, you should be able to repeat some of your experiments. Okay, I think that's rough.
I know I do
Okay.
now.
All right, go ahead and put your nail in your test tube.
That's still dirty.
All right, make some observations about your nail. Measure the temperature, observations about your copper sulfate, and pour your solution. And you may have to wait a few minutes to see what happens, 1 to 2 minutes. Do you feel any temper changes? Do you hear anything? Okay, and that is the end of lab 1.